Let's apply the addition rule for disjoint events to one more example, and this brings back our roulette examples. So remember that Appendix B has a whole bunch of reference sheets for you about what the different bets are, where the chips would be placed, etc. So we'll refer back to that page in a moment. So let's see here. What is the probability that you win on the first column or the second column? And we're placing bets on American roulette. So there's 2 0 spaces. Well, the first column, you place your chip down here, right on that first column. And the second column is this column right here, and you place your chips right there. Now that includes all the numbers in that column except for the zeros. They don't count. They're special and off on their own. So the first column, for example, is 1, 4, 7, 10, 13, 16, and so on. The second column is 2, 5, 8, 11, 14, 17, and so on. So the probability that you win on the first column or, and there's that magic word again, or the second column, when you see or, that's going to mean addition rule. So what we want to do is we want to add the probability of winning on the first column plus, because of the or, the probability of winning on the second column. All right, so in the first column, there are 12 numbers. So that's a 12 out of 38. And in the second column, there are 12 numbers as well. And they're different numbers. That's what makes this these disjoint events. So it's 12 out of 38 plus 12 out of 38. That gets us a grand total of 24 out of 38, which is, let's see, I was grabbing my calculator on my desk again, but let me do it for you guys. So 0.6316 or so. I don't remember if we wanted decimals or fractions, so whichever one, there's our answer. All right. Okay, so we found that one. Let's see. Yep, and I didn't give instructions, so I'm just going to give both fractions and decimals for our own benefit. All right, now we're going to place another bet. We're going to place a street bet or a split bet. Now, a street bet, when you go back to the appendix, let me grab here, street bets right here. It means you're betting on all 3 numbers on the horizontal row. And a split bet, while I'm at it, means you're betting on 2 numbers. So let's go back. So you're betting on the 25 street, and you place your chip right here on that line for the 25, the left side line, and that means you're betting on all 3 of those numbers, 25, 26, 27. Then you're also going to bet over here on the 9-12 split. So you're going to place your chips right, well, or chip, we're just betting single chips, right there on 9 and 12. Okay, so I want to know what's the chances I win on the 25 street, or the 9-12 split. Okay, well, let's think. In the 25 street, there's 3 numbers out of 38. Plus, on the split bet, there's 2 numbers out of 38, the 9 and the 12. So let me see if that makes sense to everybody. Here. So for the 25 street, there's 25, 26, 27. That's 3 numbers. For the 9-12 split, that's these 2 numbers. So that's 3 plus 2 more makes 5. Now, for disjoint events like these are, you might be thinking this is really simple, and it is, right? All you kind of have to do is count the spaces that work for that particular setup. What's going to be interesting is what if they're not disjoint? What if they're not separated? These 2 bets that you're making, 25 street and 9-12, they're separated by a great distance on the board, so they're not overlapping. But what if they did overlap? Then what would happen? So 0.13, I already lost what it was, 16 when we round. And there we have it. Again, remember, we usually round to 4 decimal places for probability. Now, as for what to do when they don't overlap, that's going to be what the next video is going to talk about. What if they're not disjoint? Then you need a different rule called the general addition rule. And we'll see you back here for more videos on that.